right, so the two topics today, solving an abstract system so that we have a formula, and then plugging actual numbers into that formula to get numerical answers, and then looking at graphs that have both a horizontal shift and a period change, and can we figure out what the equations need to look like. So first, looking at systems, do not panic, we are not going to solve all of these. But these are a whole bunch of systems, and they kind of look like they're sort of the same pattern, right? Yeah. So we have to be careful and look at what pattern we're talking about so that we can match up the variables correctly. So if I said all of these systems have something times x plus something times y equals some other number for the first equation, and similarly for the second one, it would be pretty easy. I could look at, I don't know, I'll pick this system right here, and I could say A is positive 3. What would B have to be, though? It would have to be a negative 2 in order for this to fit the pattern of plus something times y. And C would have to be 8, D would be 4, F would be 6, and G would be 3. And if I went to one of the other systems, some of those numbers might be the same and some of them would change. So far, so good. Now, where we have to be careful, let's suppose that instead of my second one fitting that pattern, let's suppose that we set it up that my second equation fit the pattern mx minus something times y equals g. So if I had that, then I'll look at this system right here. It's nice and convenient. M would be 4, but n would be what? It would have to be negative 6 in order for this to be minus negative 6 to give me the plus 6y, and then g could be 3. So you've got to really pay attention to the plus and minus signs when you're doing these. Sometimes you will be plugging a negative number in when you evaluate. Sometimes you have to be careful as you're setting this up. What does that mean you have? If I did this one down here, and I was using the mx minus ny equals g for the second equation, what would n have to be in this one? It would have to be a positive 5 to be minus n times y. So you see why you need to really watch the pluses and minuses. That's the hard part. Okay, let's do a system where we solve it and get a formula, and then I'm going to use those results to get numerical answers for two systems real fast. So first thing, we want to make sure that we read carefully which variable are we solving for so we don't waste a bunch of time solving for the wrong one. So we need to solve for y. So help me out. If I'm solving for y, which variable am I getting rid of, Natalie? So I want to get rid of x. So how am I going to do that? Grace? Multiply which one by what? By negative what? Okay, so multiply that by the opposite of d, and the second one by? Okay, let's try that out. Aiden, what do I get for the first equation? I knew what you meant on that. And what about for the second equation? If we multiply by I, what will we have? Abby H? And if I combine those, the x's do indeed go away. Looks like I will have AF minus BD times y and AG minus CD. So if I divide both sides by the parentheses, y is AG minus CD over AF minus BD. Does that look right to everybody? Anybody with questions at that point? Okay, let's then solve a couple of systems here. Need to make sure I can still see my original system to help me figure out what A, B, C, D, F, and G need to be on these. So looks like everything's positive, so that'll make it nice and easy. A needs to be 3. B is the one in front of y in the first equation, so B is a 2. C is the constant over here in the first, so C is 8. And D is the x coefficient of the second one, so that's going to be 4. And whoops, F is the coefficient in front of y in the second equation, so that's a 5. And G needs to be 3. Everybody feel comfortable with that? Okay, now we are going to plug those into our formula. So I'll go down a little bit lower so I have a little bit more room to write. So y is A times G, so 3 times 3, minus C times D, so 8 times 4, over A times F, 3 times 5, minus B times D, 2 times 4. So what will that give me? 9 minus 32, how much is that, everybody?
28.
Negative 23. And 15 minus 8. So that we have that. Now, let me change my system just barely. The only change I'm going to make is I'm going to change that plus 5y to a minus 5y. Everybody comfortable with that? So that means I can still use all of these, A, B, C, D, and G. I just need to change, and now F is negative 5 to make it match with what I originally had here. Then if I plug in, most of this work's going to be exactly the same. AG minus CD won't change, so I'll still have the 3 times the 3 minus the 8 times the 4, or negative 23 for the numerator. For the denominator, A times F is now going to be 3 times minus 5, and B times D will still be 2 times 4. So negative 15 minus 8 is how much? Negative 23, and so that will reduce to 1. So we get a different answer if we have some different coefficients in there. Now, where this comes into play, let's suppose that you get a job as an engineer and you design something, and maybe you get as far with the first attempt as building a prototype and testing it out in the wind tunnel or whatever. And it doesn't quite work the way you want it to. So you decide you're going to make some changes. And from your science classes, let's say, different metals have different densities, right? So maybe there's one of these coefficients has something to do with the density of metal. And then that's going to impact the weight and all that. Or maybe you decide, maybe you've got a cylindrical part and maybe you decide to change the radius. And maybe one of those coefficients corresponds to the radius. Or maybe it corresponds to the length of the cylinder. So there'll be a whole bunch of variables you could change in your invention and your prototype to see what's going to happen. Now your boss probably is not going to want to foot the bill for building prototype after prototype after prototype. Instead, your boss is probably going to want you to come up with some kind of mathematical equations that model what is going on. Way more complicated than these systems. A whole lot more equations, a whole lot more variables, a whole lot more coefficients. And probably will want you, probably not by hand like we're doing, but with the help of a computer. Well, what would happen if I change the density coefficient? What would happen if I change the coefficient that has to do with the radius? What would that do to the final result? So you kind of get a feel for why it might be good to get a formula and then be able to put different values into that formula over and over instead of just doing each system completely separately by itself. So does that make sense? Question?
What is the answer? What do we search?
On this one, if it says find the value of y, you are going to circle that y equals negative 23/7 on that one. or y equals positive 1 on this one. Any other questions about these? Because that's the only example I plan to do of these. I want to spend the rest of the time with graphs. Okay, moving on then. First one is a review. Let's get both sine functions for this one. So y equals and y equals. One will be a positive sine function. One will be a negative sine function. They will both have the same center line and amplitude though, right? So tell me what my center line is going to be on this one. Like 2. Negative 3 and positive 7 are 10 apart. So halfway in between is 5. 5 above is 2. 5 below is 2. So 2 for my center line. One of these will be a plus sine function. One will be a minus sine function. And I just said that the amplitude is 5 for both of those because that's how far we have to go between center line and max or min. We're doing both of these as sine functions. Okay, we need to figure out, do we need to change the period or is it the normal period? So I look at that and I know this max is 45 and I don't know how much this max is right over here, but I could probably figure it out, right? But I do know, let's see, what is labeled on this thing? Well, if I look at these, it looks like since this one has a grid, it looks like each box is 45, so let's check that out. 45, 90, 135, 180, 270, 360, so each little box is 45. So that means this would be 405 degrees. How far apart are 45 and 405? 360, so no period change, so we don't have to worry about that. So if I am doing a plus sine function, I am looking for the nearest center line increasing. So I believe I'm looking at this point right here. Did I get that one right? And I know this is negative 90 over here. Do I know how many degrees that is? Negative 45. So when I have the plus right here, my variable is x. I need x minus the negative 45, giving me x plus 45 degrees. And let's see, if I want to do the minus sine function, I need the nearest center line decreasing. Looks like it's going to be right there. How many degrees will that be? So that will be positive 135 degrees, so we will take x minus that positive 135 degrees, and there are our two equations. Nothing hard about that. Let's do a couple where we also change the period, though. This one we're going to do two cosine functions, plus and minus cosine. So let's see, do we indeed have a period change on this one? So let's see. Looks like maybe this max and this max are both labeled. Everybody, how far apart? 180, so the period on the graph is going to be 180 degrees, which means the number in the equation, what do I have to do for that? So 360, the normal regular period divided by what I see on the graph, giving me 2. Everybody comfortable with that? Okay, then can you figure out the center line for me? It isn't labeled. Who can figure out what the center line needs to be for this one? The min's negative 9 and the max is 3. Okay? So negative 9 up to 0 is 9. 3 more, total of 12 apart. So 6 is halfway for the amplitude. 6 below 3 is negative 3. 6 above negative 9 is negative 3. So both of these will be y equals negative 3. One will be plus 6 cosine. and the other one will be minus 6 cosine. We have figured out that we need the number 2 in front of the x for this one, so we can go ahead and put that number in for the change of period. Okay, shift for plus cosine. Read. Plus cosine, what kind of point am I looking for? I'm looking for a max. Have I shifted that from the y-axis? So no shift on that one. So we can simply say y equals negative 3 plus 6 times the cosine of 2x. If I am doing the minus cosine, what kind of points do I need to look for? So is either one of those men's closer than the other one? So in this special case, they're the same distance away. And so I just need to figure out how far that is. Now, what I know is that the min is going to be halfway between these two maxes. If these are 180 apart, these need to be 90 apart. So if this one's at 0, this one has to be 90 degrees. Since it's equidistant, I can do it either way as x plus or minus 90 degrees. Does that much make sense to everybody of how we got this? Now, a couple of things I want to point out here. This is the same as negative 3 minus 6 times the cosine of 2x plus or minus 180 degrees. But when you're writing these equations with the period and the phase shift, the period coefficient has to be outside the parentheses. The phase shift has to be inside. You can't look at it this way and say there's a shift of 180 because we know from looking at the graph the shift is really 90. If I forgot and put if I was incorrect and I wrote it down as y equals negative 3 minus 6 cosine, and I forgot and tried to put the 2x inside and still tried to put the shift right inside there, this would be wrong because this would be, this one in black would really be a shift of 45 degrees, which is not what we saw in this graph, so that one does not match. Does that make sense to everybody? Okay, one last example then. Let's do all 4. It is not as hard as you are groaning and making it out to be because so much of it is the same for all 4 of these. So, start off with center line and amplitude. That's pretty easy to come up with. Been doing that for a while. Mia, what do we have? And the amplitude was, so negative 4 and positive 8 are 12 apart. Half of that is 6. That's our amplitude. And so we have 2 plus 6 and 2 minus 6 with sign. And we have 2 plus 6 and 2 minus 6 with cosine. And we need to see if we have a period change. So let's take a look at that. And let's see, this max is not labeled, my maxes aren't labeled, neither are my mins, but it looks like all of my center lines are labeled. If I go from negative 80 to the next center line point, is that a whole period? No, that's only going to give me a right side up U. Center line decreasing to center line increasing is half a period, so a whole period goes this far. So if I have 80 to the left of 0 and 160 to the right of 0, how much is that altogether? So my period on the graph is 240. So the number that I need in the equation is 360 over 240, or 3 halves, right? So all four of these have 3/2 next. Now it's just figuring out the 4 shifts. So that's the only part that gets repeated with these. So if I do a plus sign function, I am looking at nearest center line increasing, which is at how many degrees? My variable is x, because that's how this axis is labeled. So x minus that positive 40 degrees. How many degrees do I need if it is a minus sign function? What point will I be looking at on that one? I'll be looking at the negative 80 degrees right here. So this one will be x minus the negative 80 degrees, becoming a positive 80. For the plus cosine, what kind of point do I need?
Max.
I need a max, and I believe this one's closer than the one on the left. But I'm going to have to figure out how many degrees. So I know that my period is 240. So I know this much is 120. And so half of that is going to be 60. So how many degrees will I have for that max? And so x minus that positive 100 looks like this. And then for the last one, I need my nearest min, which is right here. And I know that from a center line increasing to a min, one critical point to the next, has to be 60 degrees. So what's 60 degrees to the right of negative 80? And if I put in the x minus the negative 20, it will look like this. So any questions with that? Right. I would like for you guys to grab those whiteboards and your markers, and we will do a couple of practice problems here together.